All right, students, in this video, I'm going to go over how to formulate absolute value equations from graphs. So by now you have seen the vertex form of the absolute value equations. It looks like that. And we now understand that the vertex is the values of h and k that are found right here. So your job is to now, instead of graphing to check, you want to just teach yourself how to look at the graph, identify the vertex, because that vertex will be your HK values in the graphing, in the equation. And then you also need to calculate this A value in the front. So let me just clarify that the parent function, we have the absolute value of x, and this, even though it's just absolute value of x, it actually has a 1 as an A value, and it also has a 0 as an H value and a 0 as a K value. So this is just saying that it follows the rise over run ratio of 1 to 1. That's what that A value in the front means. And then the 0 for the H, 0 for the K, that creates the vertex of 0, 0. So notice that I press enter and nothing changes. That's the same graph as just having absolute value. So your job is now to create that equation from the graph, identifying the A value and the H and K value. So again, the A value can be found by seeing this as the rise over run ratio from one point to another. All right, so let's look at this first example. The vertex in this first example is 1, 2. That means that your H is 1 and your K is 2. So it's HK. Now for the A value, we're going to do the rise over run ratio from one point to another. So like right here, we're going to rise 2, run 3, so 2/3. Rise 2, run 3. Rise 2 over 3. Okay, so then the equation would look like this. Y equals 2/3 as my A value, x minus my H value, 1, close the absolute value, and then plus K, which is plus 2. So just to confirm that this equation is the graph that we see right there, you have your calculator. So I'm going to go ahead and graph an A value of 2/3. And then the H value is 1 and the K value is 2. So this graph, to verify that it's the graph we have in our paper, we can trace. So it has a y-intercept that is around 2.67. So we can see right here that our y-intercept's around 2 point something because it's between 2 and 3. And then you can trace it to the minimum, which is 1, 2, which confirms the vertex 1, 2. And then I can keep going to the right or just pressing values to get points. So notice that at 4, 4, there is a point, an exact point. And notice that that 4, 4 is the point that we have right there. So this confirms that this equation that we created matches that graph. Okay, let's write 2 more examples. So you start by looking at the vertex, identifying the vertex as h comma k, so it's x comma y, -2, 6. So this confirms that our h value is -2 and our k is 6. Now to identify the A value, we're going to do rise over run. From one point to another, it looks like it's touching 1 here, rise 1 down, and 2 across. So because we're going down, we're going to have a -1 and 2 across. To double check that that is true, you can always go the other way. So down, left, down, left. The fact that the graph is opening down, we know that our A value has to stay negative. So let's put it together, and we're going to have y equals negative 1/2 absolute value of x minus h. Remember that when you have x minus h, it's x minus a negative, which ends up looking as x plus a number. So we'll have x plus 2 and then plus 6. Okay, so let's graph that in the calculator. Excuse me. Okay, so I'm going to type negative 1/2 absolute value x plus 2 and then plus 6. So this confirms that it's a graph that is upside down. And then the vertex should be at negative 2, 6. So let's trace it. And I'm just going to get there. It's negative 2, 6. And then the y-intercept looks like it's 5. So notice that at 0, 5. That is correct. And then like this point right here, that's negative 4, 5. So I'm going to just type negative 4, press enter. And it confirms that negative 4, 5 is on that graph. So this is correct. Let's do one more example together. So on this one, we have a vertex right here. The values is 0, negative 4. So that confirms that we will have an h value of 0, a k value of negative 4. And to calculate the a value, we do Rice over run. So from this point to this point, it looks like it just went down 1 and 1. Notice that it's following that pattern, 1, 1. So that means we're going to have negative 1 over 1, which equals negative 1. So if you have negative 1 as your a value, that's just writing a negative in the front of the absolute value. And then x minus h, if x is minus 0, there's nothing you're subtracting, so we can just close the absolute value. And then minus 4. If you're adding a negative, you end up subtracting, so we're just going to have that. Okay, so then now let's check. So I'm going to delete this. Oops, my bad. And then just type negative absolute value x minus 4. So this graph confirms the sketch that we have here. We're just going to trace. So negative 4 is there. And then if I put 1, enter, it gives me 1, negative 5. 2, enter, and it's 2, negative 6. So this confirms that this equation is the correct equation for this graph. All right, so that's all for this video. Just practicing writing equations.